Hey folks, so this video is going to introduce you to some concepts about how friction is related to standing on a slope. So we know that if we are standing on an elevated surface, particularly like a hill or something, friction is really important and how we're able to successfully navigate a slope. So the examples here are given with like a block that's sitting on a slope, and you can imagine that that's a human being and walking up a slope with a particular angle. And so when we have something that is sitting on a slope and there's a certain amount of force that's directed right towards the planet Earth, straight through the slope, we can break that force into its vector components. So we have a force that is acting parallel with the surface, so down the slope, and then we have a vector component of the force that is acting perpendicular into the surface. So we can call that down or parallel, and then into the surface or perpendicular. And how do we know what those forces are, or how can we resolve those specific vector components? We just use our basic trig relationships, and the parallel or down force we can use mass times gravity times sine of the angle, and then our perpendicular or our force into mass times gravity times cosine of the angle. And note that mass times gravity is simply newtons. So let's say you could, if this was a human standing on a slope and you know how much the person weighed, you could calculate the newtons of the person, and then you could get these vector components calculated. We know that friction is a product of the coefficient of friction, or the Greek letter mu, times the reaction force, right? So where R is the reaction force acting perpendicular to the surface of the slope, and U is the coefficient of friction. So let's talk a little bit more about how we can use that relationship and get an idea of how important friction is on a slope. Note that reaction force is oftentimes called normal force. So if you see force normal or normal force, just realize that that is the same as reaction force as we go forward. Okay, so we know we have this parallel or force down across the surface. We have that vector component. So let's talk a little bit more about the force into the surface that's perpendicular, right? For every action, there is an equal and opposite reaction. We know that's one of Newton's laws. So we have this normal force that's coming back up perpendicular to the surface, also called reaction force. Okay. Now, we also have that parallel force, right? That force that's down across, that's going down across the surface. And the reaction force there, or the equal and opposite reaction, is our friction force. Okay? So if we're keeping track, we're talking about friction force and then the reaction force here. All right? And when we're talking about something on a surface, on a sloped surface, as the angle of the surface gets higher and higher, there is a chance that the object will begin to slide. Now, up until the point where it doesn't slide, or the non sliding component, as the angle of the surface gets higher and higher, it's building static friction, right? So, static friction is where we're not moving. There's a lot of friction between the two surfaces, and eventually we get to maximum static friction, and the maximum static friction breaks and the object starts to move or becomes dynamic, which we call kinetic friction. So sliding is kinetic friction, and that's always lower than maximum static friction. So if the block began to slide down the surface, we would be beyond maximum static friction. We would have dropped down into kinetic friction. Okay. And so we can see that if the friction force across the parallel across the surface is less than the amount of downward force that's we will have kinetic friction. Okay, so if we're looking at these relationships, what are some things we can take away from the concepts that we just discussed? We know that the force of friction is reaction force, or also called normal force, the same thing. force of friction times reaction force and coefficient of friction. That is a relationship we can use to quantify friction. This parallel or force down across the surface of a slope is just mass times gravity times the sine of the angle of whatever slope you're standing on. Remember that mass times gravity is the same thing as newtons. And then our force that's going into or perpendicular of the surface, if we want to derive that vector component, we just do the newtons or the mass times gravity and the cosine of the angle. A reaction force, same thing as normal force, just a reminder there. And then we know that because of Newton's law of reaction, for every action there is an equal and opposite reaction, this downward or parallel force across the surface of the slope is the same as force of friction, right? So that those are equal to one another, and then the force perpendicular or down into the surface is the same as that normal force, or the same thing as reaction force. So hopefully that gives you a better understanding of how the relationship of friction relates to standing on a slope, and we will discuss this further in class.